Welcome back, everybody, to our ISNCT interviews. My name is Valeria Monti, and today with me is my colleague, Dr. Ian Postuma. And it's my great pleasure to introduce our guest, Professor Andres Kreiner, head of the Accelerator Technology and Applications Department at the National Atomic Energy Commission in Argentina. Welcome, Professor Kreiner. Thank you for having accepted our invitation.
Hi, thank you for this nice opportunity.
I will immediately start with the first question. Can you briefly tell us about the main projects related to BNCT in which you have been involved during your extended career?
Yeah, let me say that we started with BNCT, in particular with a already certain view towards accelerator-based BNCT in the second half of the 90s, so almost 30 years ago. And we have gone through a number of initiatives and activities. Let me briefly summarize. One of the things, as you know, we are here in a tandem lab. We have in Buenos Aires a large accelerator, and we started using the charged particle beams for different purposes. And in particular, we set up an external beam irradiation facility where we performed in collaboration with colleagues of the radiobiology department measurements on different cell lines, both cancer cell lines like melanoma and also normal cell lines, in order to determine the radiobiological effect of low energy lithium, alpha, and proton beams. And essentially what we did is to measure survival curves, which allowed us to characterize the different radiations, different projectiles as a function of energy. And so we could determine the parameters of these survival curves and somehow go away from the first approximation, which is to take a fixed RBE and so evaluate with these parameters the dose delivered to a real system. So this is one of the activities. Then we studied also nuclear reactions, different nuclear reactions as candidates for ABBNCT, and we optimized different beam shaping assemblies for these projectiles. Also simulated treatment planning with different projectiles, and finally also studied neutron production targets. One other thing we did with the help of microbeam we have here at the Tandem Lab is to study micro distributions of potential drugs carrying boron for BNCT. We were able to measure micro distributions at the cell level and also the tissue level. Another thing we made some progress is towards the first tomographic system. This means a SPECT system specifically designed to determine the dose by measuring this gamma ray emitted in the capture reaction, and so measure and determine the dose online while the reaction is being produced. A subject which I think is quite important and is being pursued by other groups. And finally, the main activity was devoted to development of accelerator technology, of our own accelerator technology. We developed here already a full accelerator, not a full size one, but a half size because of the limitations of the lab we have. And also of most of the ancillary systems you need for operating such a system. So in short, I would say these are the activities we have performed during these years after about 50 papers and 9 PhD theses, which were carried out in the framework of this work. So a lot of work.
Yes, indeed, tons of work. And your accelerator idea is very interesting. Or actually, when do you plan your new accelerator will be ready to operate with the first patient?
Well, this is a complicated question because if we would have ideal conditions, conditions at the Atomic Energy Commission are not ideal from the management point of view. The bureaucracy is heavy. Also, the budgets fluctuate. But I would say the earliest we can think of having the machine in the lab ready is the end of next year, but most likely in 2024. At least this is an optimistic estimate of when we will be able to operate.
Very nice estimate then.
You mentioned before that you studied different nuclear reactions. And if I'm not wrong, now you chose deuteron beam on carbon target for the new accelerator. So why did you choose this reaction?
Well, I think the main idea behind choosing deuteron-induced reactions is to keep the energy of the accelerator as low as possible. You know that the main reactions being used are, in the first place, protons on lithium-7. This is a reaction which has to be carried out at about 2.5 MeV. And the other is protons on beryllium. And there you need significantly more energy, at least 5 MeV, although there are several systems operating at significantly higher energies. And these reactions are endothermic, while the deuteron-induced reactions are exothermal. And so at 1.5 MeV, you can already have significant neutron fluxes, and also at convenient energies, relatively low energy. So, and also in contrast to the lithium-induced reaction, the main product of these deuteron-induced reactions, which are two essentially, one on beryllium, the other on carbon-13, are stable. So it is true that there are minor reactions or relatively minor reactions which produce some radioactivity, but the main reaction, the main neutron producing reaction, leads to stable products. So I would say these are the reasons behind using deuterons as projectiles.
So indeed, it's a very interesting reaction, and no, you're the only ones who are proposing it. It's very interesting, and it's part of the future of BNCT probably. And so the next question is about the future of accelerators of BNCT. What do you think for example, about laser-driven accelerators? for BNCT?
Well, I must say, I'm not a specialist, but I know this work, and it seems to me that this is still too early. It is true that there have been experiments showing the acceleration of protons by these laser-driven systems or plasma-driven systems. But it seems to me that this technology is still not mature to be used. But as you know, this can change. It depends how much effort people put into it, and we will see.
Yes, we will see. I switch to another topic for the next question. In 2025, you will be the president of the International Congress on Neutron Capture Therapy. So what are your expectations regarding this Congress?
Well, my expectation is that we can contribute to promote BNCT and to make it flourish. So in order to become a widespread modality, treatment modality, and we will do our best to host this conference and to have you all in Buenos Aires in 2025.
It will be a pleasure to be there. I hope we can make it. It's always very nice to travel to Argentina. So, and about the Congress, there will be an upcoming Congress organized by us, the Communication Task Force, the Young Researcher Conference. Will you be there in the meeting in November?
Well, I will try. I would like to. I think I will be able to attend. We have submitted or are about to submit some contributions by different members of our younger members of our group. So we will participate. It's always very good to hear about the new developments and the contributions of younger members of the community. So I will be there.